All right, we're starting 3.4 here. Now, in the last section, we had put a bunch of what we had done together to ultimately be able to figure out what the graphs of these functions looked like. However, we were always given one of the zeros, at least 1 0 to start with, one or two of them. And then we kind of factored it down from there by using our synthetic division. So the question, though, becomes, what do we do if we aren't given any of the zeros or any of the factors to start with? How do we go about starting this off? And basically, what we're going to use is something called the rational zero theorem. And basically, what this is going to tell us is that we can come up with a list of possible rational zeros. Possible rational zeros. And we do this by taking all the factors of the constant term and dividing it by all the factors of the leading coefficient. So if we look at this first one here, we see that the constant term is this -8, and the leading coefficient is this 2. So up here, or I should say right here, the constant term is -8, and the leading coefficient here is 2. So we want to write down all the positive and negative factors of that, and then use that as a way for our possible zeros to essentially give us a small list of numbers to check rather than having to try and check like every number in existence. So if we do that, we see that the possible rational zeros equals that. In this case, if we look at -8, we're going to have all the positive and negative values of all the factors: 1, 2, 4, and 8. So +1, -1, +2, -2, +4, -4, +8, -8. And I'm taking care of all the positive and negatives by writing that positive negative out in front there, that plus minus. And then we need all the possible factors of 2. And that's going to be a plus or minus. And again, sorry, not just 2, but 1 and 2. Those are our possible factors for that. Next, what we need to do is go through and group up all of our possible ways we can group those together. So if I look at this, I can see I can do 1 divided by 1. So I can do a plus or minus again, because I can have each one be positives or negatives. I can have 1 over 1. I can have 1 over 2, right? So 1 over 1, 1 over 2, like that. And then I can go to the 2, and I can do 2 over 1, 2 over 2, and then I can go to the 4. And so I'm just going to make all these possible combinations. So 2 over 1, 2 over 4, 4 over 1, 4 over 2, and 8 over 1 and 8 over 2. So those are all of my possible factors here, rational factors. And what I can do is then next is just reduce them all and then get rid of any duplicates. All right, so again, I have plus or minus. 1 over 1 is 1. Then I have a 1/2. Then I have 2 over 1, which is 2. I have 2 over 4. That's a 1/2, right? This 2 over 4, that's a 1/2. So I've already done a 1/2. And then I did do 2 over 4. Yes, that should be 2 over 2. My mistake. Thank you. 2 over 2. I wrote 2 over 4. Anyway, that's 2 over 2. That's a 1. And we already have a 1. So that's just a 1. 4 over 1, that's a 4. 4 over 2 is a 2. We already have a 2. 8 over 1 is 8. 8 over 2 is 4. We already have a 4. So we already have that. That's a 4. So there we go. There are all of our possible rational zeros. So if we were trying to find all of the zeros, what we would then do is go through and just try synthetic division with each one of those. if we were trying to factor this down, and you'd see which one of those actually gave you a remainder of 0. If it gives you a remainder of 0, then it stops just being a possible rational 0 and is actually a rational 0. All right, so that's just a list of them. Again, it's +1, -1, +1/2, -1/2, +2, -2, +4, -4, +8, -8. So we have 10 different possibilities there to try. Not all of them will be zeros because this has at most 3 zeros because it's to this third power here. It's a third degree one. So we can't have more than 3. So at most 3 of those are going to be zeros. So, all right, I'm going to go ahead and pause this and see if there are any questions, and we'll work through the next one. All right, if you're just watching this later as a video, there are number 2 and 3 done. I'll leave in number 4 for just people to try on their own if they wanted. So we're going to move on over here and take a look at using all of our tricks, everything we've done so far to try and graph this. And we're going to go through these steps. And these are good steps in an order you can follow. So the first thing we're going to do is look at the degree, the leading coefficient, and use those to determine the end behavior. So if I look at this, I see this is my leading coefficient out here, and it has a degree of 3. So a degree of 3, that's an odd degree, and therefore it's going to act like an x cubed, which it is an x cubed. The leading coefficient is a 1. And so we don't have, it's not negative, it's a positive thing. So this is going to look just like an x cubed, where it's going to fall to the left and rise to the right, or as x goes to -infinity, y will go to -infinity, and as x goes to +infinity, y will go to +infinity. So that's what's going to happen with that. Next thing is factor it if we possibly can. If we can't factor it right away, we can use the rational zeros. We can find all the possible rational zeros and then use synthetic division to find if they are actually a 0. And then, just kind of then factor that one out. And then if we need to, try and factor the next one. If we can't factor it, find the possible zeros and keep going until you slowly break it down into its factored form here. So let's take a look here. We have x cubed plus 2x squared minus 6. So we have to do all the possible factors of -6. That's going to be plus or minus 1, 2, 3, and 6. And we need to divide that by all the possible factors of this 1 that's in front of the x cubed. So that's just plus or minus 1. So that just leaves us with positive, negative, 1, 2, 3, and 6. All right, then the next thing I want to do is actually just go through and start trying these. So I have no reason to pick one over another. So I'm just going to start with the very first one, which is 1, positive 1. And then I'm going to try and use synthetic division, divide our original function by it, and see if we get a remainder of 0 or not. So my coefficients are 1, 2, -5, and -6, just like that. I'm going to bring that 1 down, and then I have 1 times 1, which is 1. 2 plus 1 is 3. 1 times 3 is 3. -5 plus 3 is -2. 1 times -2 is -2, and that's a -8. So no, this is not a 0 because we didn't get a remainder of 0. So I'll go to the very next number, and that's -1. So I'll try -1. And again, I'm going to divide it into the same thing, our original function. So I have the same coefficients here, 1, 2, -5, -6. Doing the same thing, but this time with a -1. So I'm going to bring my 1 down. And then -1 times 1 is -1. 2 plus -1 is 1. 1 times -1 is -1. -5 plus -1 is -6. -1 times -6 is 6. And -6 plus 6 is 0. Therefore, this works. That is a 0. So this works. This is a 0. Has a remainder of 0, so it works. That means I can take our original function and I can rewrite it with that factored out. I can rewrite using this right here, which will be, we reduce the power by 1. So instead of x cubed, it's x squared plus x minus 6. And then I just factored out, I found x equals -1 is a 0. That means x plus 1 there, that's our factor, right? The factor is the opposite of what's there. So now I have the first part factored. And now I look at the next part here. I just look at this first part out here and say, all right, now I have to go through the process of trying to factor it. So I look and say, can I just factor it on its own? And the answer is, yes, I can. In fact, that one's not too difficult to factor at all, because when you look at it, you see that you need two numbers that multiply to give you -6, but add to give you +1. And that's going to be x plus 3 and x minus 2. And then I can carry my x plus 1 down. And now I have this thing fully factored. So this is our original function. This equals our original function that was the x cubed plus 2x squared minus 5x minus 6. Those two things equal each other. It's just now we have it in the fully factored form. All right, so we know what our zeros are. Our zeros are going to be -3, 2, and -1. Those are our zeros right there. All right, then the next step says determine the behavior of each zero. So our zeros again were -3, 2, and -1. So these were our zeros. Then we need to determine what is the multiplicity of each of these zeros, because if we have an odd multiplicity, then it's going to cross the x-axis at that point. If we have an even multiplicity, it's going to touch it and turn and not cross it. So the multiplicity for each one of these is 1, because every one of those has an exponent of 1 up there. All right, they all have that exponent of 1. Let me do it in a different color in red here. So 1, 1, 1, that's what they all have. Therefore, they all have multiplicity of 1, just like that. And then our last thing is, what do they do then because of that on the x-axis? Well, every one of them has an odd multiplicity, so they're going to cross, and cross. They all cross the x-axis at those locations. All right, after that, we just go through and determine our y-intercept. We do that by plugging in 0 for x, right? Set x equal to 0. So we get y equals 0 cubed plus 2 times 0 squared, right? I'm taking it right here from our original function, minus 5 times 0 minus 6. 0 cubed is 0, 2 times 0 squared is 0, and 5 times 0 is 0. So we're left with just y equals -6. All right, there's our y-intercepts. So now we have all of our x-intercepts, -3, 2, and -1, and we have all of our y-intercepts. And so the last thing we have to do then is put all of this together, all of these bits of information. So our intercepts are what they do across on those intercepts, and our in behavior. So we're going to put all that together. So first, let's start with the in behavior. So the in behavior is that it's going to be going down over here, and it's going to be going up over here. Next thing I want to do is put in all of my x-intercepts, which is my zeros. All right, I'm going to zoom in here a little. My x-intercepts are -3. All right, that's this one. At 2, that's that one. And at -1, which is right there. So there are my 3 x-intercepts. And then I want to look at my y-intercept, which is down here, which is -6. So I can put a dot there. I know that at each of those x-intercepts, it's crossing it. So whenever I draw my line, I have to cross each one of those, not touch it and turn, but actually cross. So when I come up here to this one, I'm not just going to touch and turn like that. That would be wrong. I have to come up here and cross it. Then I have to turn around and I have to cross there. I also have to cross our y-intercept, and then I have to turn around and come up here and cross right there and go up just like that. So I just drew a line in that fits all of our criteria, hits the x-axis everywhere it's supposed to, crosses it just like it's supposed to. It has the proper in behavior, and it has the proper y-intercept. All right. So that's our basic method for going through and doing that. So it's the same as like what we were doing last time, except this time we have to start off by finding all of the zeros because we're not given one. All right, so let me go ahead and pause this real quick. We'll see if there's any questions before we start moving on.